Second now.
Excellent.
Okay. Hi. Welcome.
So
this is the UNIX shell tutorial. So if you haven't, if that's not what you want to learn, then now is you shouldn't be here. So I'm Titus Brown. I'm a professor here in VetMed. I think about half of you or a third of you I've seen before. I am a computational biologist, bioinformatician, genomics person, whatever, that is running a training program, and I call it the DIB training program for data-intensive biology. And the goal is to provide a variety of workshops and venues for people who are doing basically data science and biology at the same time. So generally with sequences, but we can talk about other things as well, and are interested in either learning the basics or experiencing the basics again, or leveling up in various ways on their stuff. So there's a couple different things, and I'll tell you about some of them in the next slide. But the basic thing is I'm over in the Center for Companion Animal Health. I'm on campus a lot of the time, and I'm always happy to receive email, and generally I respond within a week or so. So please feel free to contact me. If you don't have my email address, you can find CT Brown at UC Davis. So this is the first of the fall workshop series that I'm going to be running. There are going to be 10 workshops in the fall. All of them are introductory. There's some listed on the right. They're not yet posted, so you won't necessarily. They'll be posted on the mailing DIB training page, and I'll send them out to the training mailing list on the next couple of days. Basically, be going through later in October, we're going through Open Refine, which is for working with spreadsheet data, which is a surprisingly awesome way to take spreadsheets that have many thousands of records, often hand entered, and work with them. Less genomicsy, more ecology, spreadsheety. We'll be doing introductory version control with Git, Amazon Web Services for cloud computing, and then another introduction to Unix shell, which will be the same as this in November, and then we'll just be repeating those. And then we also run office hours every Wednesday, 3:15 to 5:30 over in the second floor of CCH. So if you're running into any problems whatsoever with any data analysis or any computer problem, I mean, I'm not sure we can help you with like Windows install problems, but if you're running into data analysis problems, please feel free to come by and ask questions. You can also just hang out and work on your data analysis. And if you run into problems, there are a bunch of people there who can help you. So that's what it's for. And then again, all of this will be announced. All of this is announced regularly on the DIB training mail. And I'll send you all a link to that after the workshop. You have to sign up for it in order to get the emails. I don't automatically sign people up. Any questions? Okay. Couple things to start with. This workshop's under code of conduct. The basic version is don't be a jerk. And often people are inadvertently jerks when they sort of know too much and feel like they shouldn't. They know too much about what I'm talking about, and then they start telling other people about how much they know. It hasn't ever been a problem in these workshops, and I'm hoping that it will never be. I'm just saying, if you're bored of presenting, that's fine. You can switch to Facebook or email, or you can wait around to see if I get something interesting, or you can help people that are running into trouble, and I'll tell you how you can figure out who's having trouble. Anyway, the main point is no one knows everything, and even when you do, even when you think you do, being friendly and helpful is a great approach. So, great way to meet new people. So, you should all have 2 sticky notes. Yes? Could you toss me there's one. The yellows, is it yellow? Blue? Sorry. Okay. Well, the blue sticky is good. It means you're done and you don't need any help or input. The red sticky is I'm stuck with something. And if you put it like this, then I can see it. And I can look around the room, and if like 4 of you are stuck with something, then I won't move on. And if 1 of you is stuck with something, I may dispatch a minion. I don't have any minions today, but I may dispatch myself to help you and then not progress until everybody's copacetic. So this is a good way if you look around the room and you're done with everything, and there's a red sticky right next to you, you can move over and maybe try and help them if they're interested. Or you can wait for me. Okay? So that's how we know. And so the key point about the spaces is to put them up somewhere where they're visible to the people behind you also. Sometimes that's where the helpers are. So if you put them here, that doesn't work so well. If you put them here, that works better. Okay, and Karen? Frisbee. It is a frisbee. All right. So, okay. So let's see, what else do I want to say? So that's pretty much it until before we get to the content. I said there's all these other workshops. There's actually also a bunch of other training stuff on campus. The Bioinformatics School runs training. There's HPC training for the on-campus computers. That's just started up. The Davis R users group is also runs regular office sessions. And I'm happy to point you towards these if you have questions. The scheduling, the Davis R users group, I think is every Thursday, and I forget what time exactly. They do everything, not just biology, although there is a lot of biology in it, biologists in it. And I generally forward announcements onto the training list if you're on that. So, and I forgot to put up the schedule slide. We'll probably break for coffee, decompression, bio break at around like 10:30. And then there's some cookies and coffee in the back. You have to save me one of the macadamia nut cookies. We'll break for like 15 minutes, then come back, and then around 12:15 or 12:30, we'll quit for good. Oh, one last important comment. You may have seen all the technology over there. I have a computer that's live streaming this to YouTube, whatever. Questions that you ask will be recorded, but just so you know, your image won't be recorded. So if you're not okay with that, let me know and I can turn off the sound, or I probably should have said that in advance. But in any case, I will send out the YouTube link so that you can look at it later if there's something you want clarification on, or you want to go over something later. All right. All right. All right. With no further ado, then I will get started. So that was the generic workshop introduction. This is the more specific workshop. So we're going to be talking about the shell, Unix shell, and Bash. These are more or less all synonymous. There's actually many different types of Unix shell. Don't worry about it. Bash is one of the most common ones. It's always available. So if you're on a computer, you can always have that has any shell whatsoever. It probably has Bash on it. This is actually originally a data carpentry tutorial, and I can talk more about data carpentry later. Data carpentry is a global training organization that runs workshops like this. And all their material is freely available online, and you can go look at it. But I'm actually going to be presenting a lot of it over the next 6 months, so you'll see it. You'll be able to get it in person. So the objectives for today are to explain what the shell is, how you access it. That's what we're going to be doing in the first like 10 minutes. How you use it and what it's good for. So basically things like running commands, storing files and folders, manipulating folders and files, and automating actions. And really, we'll say this again and again, the first like 3 things, running commands, sometimes you have to do it via the shell if you're doing bioinformatics. Storing files and folders and manipulating files is something you can do a lot of ways. The real key reason you want to learn the shell is because it's useful for automating things. Lets you automate long-running workflows, pipelines, programs that do data analysis so that you can start something and walk away and let it run. This is really important for things like when you do big compute analyses that take days or weeks. You really don't want it to be like, okay, I wonder when the first step is going to be done so that I can move on to the start the second step. You really don't want to be sitting there waiting for it. You want to just say, do all these things and let me know when you're done. And that's sort of the model, that sort of batch computing model, that big data analysis, which is really anything that involves sequencing data analysis these days, operates on. So the shell is, for better or for worse, sort of a prerequisite for doing any real large-scale bioinformatics these days. And that's one of the reasons why I'm teaching it and why we teach it as part of data carpentry as well. How many of you have some experience with shell? I know some of you have been to some of my workshops before. Okay, so about half. That's great. I tend to, as I sort of implied in the slides, I tend to go at the pace of approximately the least experienced people in the class, and that's for two reasons. One is that once someone falls behind, it's all over for them, and they might as well not have come. And the other is that often people who have experience with a shell don't have a systematic knowledge of it, and so sort of walking through it is. And I should say, I learn something new about the shell every year, and I've been using everything we talk about here. I've been using for over 25 years, so it's sort of it's like the biology. Like there's always another thing you can learn, and whether or not you like that, it's a fact. So okay. Right, so, and at the end of this, there are some resources we went for. I think one of the things we're thinking about this is we're going to finish this whole tutorial today. And in fact, I may never go through this whole tutorial in any workshop, but you can. So you can skim through, you can refer back to this. These materials will always be available. This material has been available for over a year at this URL, but materials like that are available. So you can always go back to it if you have a specific question, or you can come to the office hours. So it's office hours are MAD, M-A-D, meet and analyze data. Anyway, we're trying it. It used to be data therapy, but therapy has connotations that people didn't like. So no, I don't want to do that. I want to do this. Okay. Okay. So just to get started. Unless there's questions, no. Okay. So what's the shell? The shell presents a command line interface, which allows you to control your computer only using the keyboard. You don't need to use the mouse at all. That's actually really useful when you're working on remote computers that don't know about your mouse. So if you're working on a HPC computer via SSH or the cloud via SSH, they don't know about your mouse, and the mouse actions don't get transmitted there. And so typing is how you interact. We've sort of gone a little bit over this. There are many reasons to learn about the shell. I should say the shell is an alternative way to interact with your computer versus using the mouse to drag files around and double-click on programs. On the Mac, which almost everybody has, I would say we're about, well, half to two-thirds Mac. On the Mac, you can actually do almost everything via the shell without ever using a mouse. But it's, of course, more difficult. Windows is a little more tricky. But there are many reasons to learn about the shell. A few of the specific ones that might be motivating you all is for most bioinformatics tools you have to use the shell. So if you want to do any kind of bioinformatics, the shell is sort of here, unless you're using CLC Workbench, but or some of the GUI programs. But even those are somewhat limited in their full range of capacities. The shell gives you power, so you can basically get to the point where you know what to do on one file, and you sort of do your full RNA-seq, 20-odd samples, 50-odd samples, and you get a workflow working on one of those RNA-seq samples. Once you get it working on one, getting it working on the next 49 is more or less trivial, depending on how you set it up. That's called scripting. And this is where knowing how to use a shell really ends up being transformative, because there's two problems with doing the same thing 50 times in a row. Anybody know what the two problems are? You probably guessed one of them. So you jumped ahead. So that's yes. When someone says do the same thing, the same 1 hour task 50 times, what do you think? Right. No, I don't want to do that. Okay. And the second problem is you get bored and you do the wrong thing 1 out of 50 times, and you'll never know. So that's a problem. Okay, and then so it's efficiency, boredom, and also the correctness. And then, of course, the other thing is that to use remote computers or cloud computing, you need to use the shell. So it's sort of required. So we really push on the automation front, which is basically to say that anytime you find yourself doing the same computational task more than a few times, it's probably worth automating it. So there's this sort of great diagram where you sort of, if you choose to divide the world into geeks and non-geeks, then the non-geek will do things not manually, analyze their data, analyze their data, and as the task gets bigger and bigger, they're still winning, because as soon as the red line, the person like me is really bored with doing things manually and decides to automate stuff, they start to take a lot more time because they're putting in all this effort to make things, document things, write things down, make things explicit, automate them, write a script, and so on. And as the task size gets bigger and bigger, there's still a gap. And then at some point, the task size gets big enough that the person that automated things just wins. I think that's the non-defensive at that point. And so the question is, what are the units? Right? And what's the time spent? What are the units on the next line?
And that's going to vary.
That's going to vary by task. It's also going to be vary by training.
So I have to tell you.
I have to just be sort of upfront and honest. This workshop's not going to solve your problems for you.
What it will
do is show you the way of thinking and the way of interacting that a lot of data scientists and mathematicians use, give you access to additional resources, and then give you sort of a starting point for doing stuff. So the way I'm using these terms, we have this meet and analyze data so that you leave here, you forget everything I've ever said, and you're like, well, I'm never going to go back to this. And yeah, there's a YouTube video, but who wants to watch 3 hours of Chinese talking? You can come to the meet and analyze data and say, I have this problem. Here's my data, and you can actually get started. So don't worry about coming to the office hours. Like, I forgot everything you said, but I still want you to help me. That's totally okay.
And the goal is
the point where you can figure out yourself which line you want to be at any given time. I do blue line a lot. Right? There's a lot of tasks, so I do them twice. I don't automate them.
But I also have more fun automating things. Is the problem? I have more fun automating things. Now I like automate things preferentially. Take longer because it's more fun than.
It's sort of a
curse.
And then there's
this handy chart. I don't know how many of you are familiar with the strip, but
there's this handy
chart.
How long
making it more efficient, or you're actually saving time. So if you have a task that you do, it takes 50 times a day, and you chase one second off the task. You will save a day of your life across 5 years. So that may or may not be worth it. But if you have a task you do 50 times a day and you shave 5 minutes off that task, you're saving yourself 9 months of your life over 5 years. You can start a family in that time, right? Anyway, right? And if you have a family, you need all the time you can get. Okay. So, right.
If you don't read SKCD, it's awesome. Anyway, the top link isn't a good one for this, but so this is fun.
Sometimes it get overwhelmed thinking about the amount of work that went into the ordinary objects around me. So, like, think about the lamp and the glass. How long people spend making sure designing those things before they sold millions of them. Anyway. So, okay. So today what we're going to do is we're going to go through how to access UNIX and Linux and some of the basic shell commands. And I'm going to throw around a lot of these words, and I apologize. Like, I have spent far too long doing this. I no longer notice when I equate Unix and Linux and Bash and shell all in one thing. They're all different things. They're all subtly different. Don't care about the difference. It's fine. I apologize. So the shell. So the challenge with this is that it's not really that simple. It's a powerful, which means you can do horrible things to yourself with it by accident. It's got its own internal logic with lots of details. So it's like the reason we call things data carpentry and software carpentry is because there's sort of craftsmen, like I have to learn how to use the tools in order to do the job. And you really have to learn to use the tools, and just like carpentry tools, you can do that thing. And there's a joke that we have about Linux, which is that Unix is really super user-friendly, as long as it considers you its friend, which can be true. So, all right. So, and then there's some cheat sheets and stuff that you can go to if you're interested in
more details. You won't need them in class today. Okay, so how to access it.
So all of you received an email, I hope, asking you to install certain things. Yes? Okay. Some of you will even have done it. Excellent.
Those of you with Macs didn't need to install anything. Those of you with Windows needed to install something or have something installed. And so the way you do this is on Windows. This is a tricky bit. Well, actually, I'll just show you.
On Macs, you go through Terminal, and available through Terminal. You go to Applications, Utilities, and Terminal, and then click on Terminal. Sorry, there's formatting on the line there. And then for Windows, you should be able to run git bash.
So everybody should get to the point where they have, on their computer, they have something where when they hit the return key, like
it just scrolls down the screen. It may not look like a %, it may look like a pound sign or something. And I'm happy to. So this is gonna be a test of a sticky system. Please put the blue sticky on the back of your computer if you have this kind of text screen.
So did you say that you have to have the % sign?
It doesn't have to be %, it can be anything. It should be like on yours, it should be some complicated thing related to the network, followed by like a pound. But when you hit enter, like stuff should be just sort of on the screen. All right. I should keep on going. Okay. I didn't send you the install, sorry. Okay, you'll note that yours does not look as cool and svelte as mine, just blue background with white text. You can change that, and if you go to preferences, you can change the font size. The most important command for you right now, is probably on a Mac, is Command+, which will increase the font size. So if it's this tiny little window and you're having a hard time seeing it, I'm old, so I have a hard time seeing anything. So like I like the big contrast. So this is pretty much how I use the shell. I have one big window out, so even I can see. And on Windows, I don't remember, but it's edit preferences somewhere in there. And because it's sort of a power tool, the set of options you have for configuring it are manifold, and you can spend hours like hitting just the right thing, and then you like get a new computer and you have to remember what you did, and it's all bad. Okay. So if you're there, type PWD and hit enter. Hang on a second. Okay, so if PWD something, it won't be /bar. /bar will be probably something that really on Mac it'll be your username, and on Windows you get something default and backslash.
I have seen some /users.
Okay. Okay. PWD stands for Print Working Directory, and it tells you where all of the commands. The working directory is where all of the commands that you're running look by default for files and stuff. Okay. You can all take down your stickies now that Karen has her done. Excellent. Perfect. So why PWD? Why? I mean, this is arcane, right? Like PWD, like. I'm gonna have to remember PWD. Why is it so short? Any thoughts? I mean, why not is actually a pretty good response, but like there's actually a specific set of reasons why the commands are all these tiny little commands. Speed of typing, a little bit, yeah. But I type pretty fast, like 5 characters versus like doesn't really matter. So Unix. So the real answer is Unix was invented in the 60s, and so people using Unix tended to dial in over phone lines that were very slow and type their commands over phone lines. And so it mattered, like each command you typed was actually like a significant burden on your data connection. And so it actually matters that the commands are, I think that's the reason the commands are short. And that tells you something important, which is why I mentioned it. It's not just a cool historical fact. Like Unix basically, sort of 80% of Unix is unchanged for in the last 50 years, right? For better or for worse. So there's this like rich history, for better or for worse, and there's a lot of commands. And one of the reasons I keep on learning new commands in Unix is because people keep on like there's stuff that I've learned that's 30 years old that I didn't know before because it had already existed for 20 years and sort of complexified it. And it's also interesting to think about the power. If you're a computer buff, it's interesting to think about the power of an operating system that has survived more or less unchanged in its primary for 50 years, even the advances of computers. So maybe there's a reason. Maybe not. Maybe it's just chance, but it's interesting to think about. Okay. So the other thing you want to do So you want to remember this path, and you want to download a file. So now go to your web browser and see if you can download this file shell-data.zip. And when you download it, you have to find it and then move it to the directory that that your shell is in. So my directory is /tmp/bar. So what I need to do is take my downloaded file, which is in my downloads directory, and let me download it again. And then I can drag and drop it from here into temp. And it'll be 10 bar is the directory. All right. So you should see in your file browser on your computer, you should see shell data in your whatever directory it is. And when you've got that, go back and type ls, and you should see shell-data.zip show up in ls. And please put a blue sticky up when you get to this point. Okay? So download. Scroll down a little. Scroll down a little bit more. It is here. Okay. It should be in your email, but yeah, it's actually in your feed. So scroll down. Okay. Okay. I'm just going to check to. I should check to see. Okay. I'm happy to help if people are lost. This link that you're supposed to click on is just down in the README. If you search for Linux or starting with the shell, it's at the bottom. Blue stickies, if you're good.
Not seeing the.
Sure. Well, see now I've. That's okay. Okay, so it's there. And you have a really good point, which is that where the heck to go. So open a new window, a new Finder window. I think you would go to File and And if you go to desktop, I'll show you Keep Track. Just click, hold down Command and click on that, and on that, and now drag it here. Okay, so I just showed Ms. Bowles a cute trick in Mac, on the Mac that might solve some problems for people, which is suppose you're here, suppose you're somewhere, and this downloads directory folder is under your main account, and you want to know exactly where it is. If you hold down the Command key and you click on Downloads, you'll get a list. So if you want it, your user's directory is right above Downloads. Okay. Okay. Good. All right. Okay. No worries. Yes, so go down, find it. Take the shell data zip file. I think maybe sort of like date modify. So, and then take that and then copy it. click on the file. Whoops, I was at that one. So I now right click on it and cut. And now go find your user directory. So you have to find the directory. So if you go to the Windows Explorer, so what is it? The sort of file directory explorer. Yeah. And you go to where's your computer? So click on this PC. And click on C. And use. There's so it's, they have each one artist and then and now you should be able to paste. Let's see if that works. All right. And now double click on shelter. Let's see if that works. No, that one. Sorry. Right click on it. Extract all. And just say it. All right. Yeah. Okay. And now you go to your shell. You now use LS. So you should see shell dash data. All right. Excellent. So double. Yeah. Okay. All right. So everybody's good. So sticking down. Excellent.
Okay, and I am going to remember to unpack mine. So I'll do that. Okay, and so you might have to do one more command. We'll get to it in a second. So if you type ls, you should now see something like shell-data, zip, and data. You may have many other files in there if it's in your home directory, but you should see those two things. So before we continue, I just want to point out one thing that you may have noticed. There's equivalence between what you're seeing in the Finder window and via the graphical interface with the files and folders, and what you're seeing here with ls. ls is listing the files in this directory, and your file and folder interface is showing you the same files, just with more information than ls is showing you right now. So I think the main point is anything you do here is going to be reflected there, and anything you do there is going to be reflected here, as long as the locations are the same. The tricky bit is getting the locations to be constant. Okay. So if you have a directory that's shell-data, we'll get to that in a second. Okay. So the first command, so we use two commands, pwd and ls. And these are programs that you run in the shell prompt to do things. pwd is print working directory, and ls stands for list files, another one of these tiny little acronyms, not acronyms, but little truncated. So another command that we're going to use is cd, which stands for change directory, and that's change your working directory. So if you type cd data, and this won't work for you, so hang on. But if you type cd data and you type pwd, you should now see that you've changed your working directory from wherever you were to wherever you were with the subdirectory data. In your case, what you need to do is type cd space shell-data and hit enter, and then cd data again. Did that not complain? Okay. Okay. And now that you've changed directory, if you type ls, oops, sorry, I have too many windows up. Okay. If you type ls, you should now see this. You should see something like this.
Sound good? Okay, put up a red sticky if you don't, but blue sticky's fine. You don't need a blue sticky. So what you've done is you've changed your working directory, and now you're in this directory that has all these files. So, and if you went into that data directory and on your file, your Finder view, you would see these same files. They look different because their LS is a very sparse view of your files.
And so this is where what we've done here is
We changed our working directory to a directory that has a different set of files. We listed those files, and those files are now available for your default commands as a default location for your commands. Do you just run into trouble?
Sure. Yeah.
Okay, so you're already in. Okay, yes. Okay, yes. So you install. Perfect. Yep. Perfect. Good. Yep. Okay. So one thing to note: if you CD somewhere,
You've now changed. It's sort of like you've gone into a room. So if I go into temp bar data, so I'm going to use this command clear to bring. Actually, I'll just do this. Clear will clear your window. So if I'm here and I'm in the data directory, if I type cd data, it's going to tell me no such file or directory.
but it just worked a second ago. Why did it work a second ago and not now? And the answer is, before I was in a directory that contained another folder called data, and now I'm in the data folder, and the data folder doesn't contain a folder called data, so I can't change into it. So one of the things that you develop as you're working with the Unix shell is a sort of memory for the short-term memory. What room of what directory, what folder, what room of your hard drive are you in, and what's available to you there versus what's available somewhere else. And this is probably the #1 frustration and complaint with shell, is that you have to keep track of not only what files are in the directory you're in, but what files are where relative to that. And that just is annoying, and we haven't figured out a good way. I'll show you a diagram of how to think about it, but it's just annoying when you have to develop the short-term memory.
Okay.
Okay.
So we also used when we did this CD data.
We did something different from before. We had to extend CD, and then we put a space, and then we gave it an argument, data.
So the command
So the
data
command data is the verb.
the command CD.
The command is the verb, right? Is the verb.
And data is
the argument or the now active verb is acting on. So CD stands for change, and data directory is the directory to which to change. So, okay.
And so there's a special directory name called .. And what .. is
Says go up one folder, go to the enclosing folder. And so you can always go back. If you cd into something, you can always go back by typing cd ..
And now, if you type ls, you'll see your original list of files,
which should be, in this case, something like just data, somebody may have shell data, that's it. Okay. We're all good? Okay.
And if you now give ls a directory, you say ls data,
It will actually do the same thing as if you'd done cd data and type in ls. But now you're saying just list the locations of this directory rather than changing it to it first. So the command sort of can work successively, one following the other, sort of modifies what the commands do.
So one problem, okay, so right, so when I said
ls data is equivalent to changing it to the data directory, typing ls, and changing back out. You'll find this a lot. There's a lot of these sort of shorthand.
So if we go back into the data directory, so cd data again, and I'm going to clear just so it's at the top of me, and type ls,
you'll see this set of files. If you don't see this set of files, then you should see my sticky slide on it. If you don't see this set of files, then flag me down. Good.
go G.
Need help? Sorry. Yeah.
Okay, so you type cd .. many times, you'll keep on going up. It won't just stop working. cd .. Okay.
Yes.
Unix is very picky. CD,
There's a difference between, I don't know if this is what you did, but I'm inquiring. If you type
cd ..
it doesn't work. It'll say command not found. That's because commands are separated, have to be separated from the arguments by a space. So you may not see the space in the all this in the tutorial, but it's there. And so cd dot dot with no space doesn't do anything at all because there's no command named cd dot dot. It's cd is the command with the argument dot dot. It'd be like typing cd data, which is looking for a command called cd data rather than cd running argument data. So okay, questions? Okay, so in here, mixed up together are all these things. And if you're on Mac, here's another cute trick. You can type open dot, and it will actually open a folder view of this directory. I don't want to show you too many of these tricks because this won't work if you type open dot on a remote computer. It won't start it up on your laptop, sadly. It won't figure it out and start it up on your local computer. But I'm just doing it here because that way I didn't have to go navigate. So you see all these files. And so here you can actually see something. So there's a directory there's a folder called hidden, a folder or a directory called hidden. There's a folder or a directory called myc. There's 3 image files, 4 image files. There's a readme.md, whatever that is, and there's a hello.sh, whatever that is. You can sort of see which ones are folders or directories here. But if you just type ls, you don't see that. You just see a list of names. And so there's a bunch of arguments that you can give to ls that will give you information. So ls minus f. Look at the last character of the names. On myc and hidden, now there's a slash. On hello.sh, there's a star, and on the others, there's nothing. And what the slash tells you is this is a folder. And what the star does is it tells you it's a program. Everything good? Okay. You take down the sticky? Perfect. So right. So that's an arcane, right? This is how you can impress your friends. Well, I don't know if you really want to impress your friends, but this is how you can impress your friends by showing them you know what minus capital F does to Alex. And so the next natural question is, okay, so there's another command that I want to show you, which is to use ls minus f, and you can also use ls minus l. And I should note minus f is capital F, and minus l is lowercase l. And what minus l does, probably the only ls command that I actually use a lot, argument that I use a lot, it gives you a long listing, which tells you how big the files are. So here you can see that hidden and myc are directories. They're quite small because the directory, it doesn't tell you how big the directory is. What's in the directory just tells you that it's a directory entry. Nano1.png is 31,000 bytes. And gbng.jpg is 101,000 bytes. And there's when it was created, and there's who it's owned by, and these things will vary depending on what computer you're on.
What does F mean? Because I'm thinking it's like L for long.
Yeah. I have no idea what the F stands for.
So there's no way to like.
Sometimes there is, and I think everybody invents their own mnemonic system.
Yeah.
But what you're really asking is exactly the next, your plant, clearly. It's exactly what's next in the tutorial, which is how do you figure this stuff out, right? So there's actually a couple ways you figure stuff out. One is you read the documents. This is actually not the way anybody I know figures stuff out, reading the manual. Because the manuals aim to be complete rather than helpful. And to show you an example of that, if you type man space ls, I don't know if this will work on Windows. Type man space ls, you get this, and that, oh, this is useful. The ls is directory contents. And then, I don't know, you see the dash kbcfgh logo. Those are all of the command line options that ls takes. So, you're like, okay, well, how do I figure out which one I want? Well, conveniently, there's a long list. Right? So if I ever want to remember what minus, if I ever want to know what minus u does, I can find out. But this isn't going to tell me how to do things with this program, particularly. Right? I mean, I look at this occasionally, but to be honest, what everybody does is they use Google and say, how do I list the contents of a directory in reverse
order of size. And then you find this stack exchange is a common one. And then, hey, look, how to list files ordered by size. And then you see someone helpfully says, ls minus L capital S does it. Does that work? I don't know. ls minus ls. Look at that. It lists the files in reverse order by size. This is how everybody I know learns to do stuff. They type it into Google and they go, eh. If you want to know what an error message means, you Google it. Because usually computer error messages are like the least helpful thing on the planet. So same thing, right? Google is your friend. There's a joke, sorry, there's a lot of bad jokes around. So do you know why the engineers at Stack Exchange have the hardest job on the internet? Because when Stack Exchange breaks, they can't look up the answer. Yeah, okay, so that's funny. Okay. So so this is how people figure stuff out. Is you basically Google it. And so the ones I remember minus F because it was like the third command I learned in like 1988. I remember minus L because I use it all the time to find out how big files are. And everything else, I just Google. And that's really not. And I have been doing this for a long time. So okay. And I should say one other thing. You don't have to scroll up to find this, but it's at the top. There's this explain shell. Where is it? Sorry. Information on the shell. There's this explainshell.com website. Suppose you want to know, like, what does ls minus L do? It tells you minus L stands for use a long listing format. So there's like a nearly infinite amount of sort of helpful websites on the internet to help you with this. I don't bother remembering them because again, like now it's a meta problem. Like there are too many helpful websites to remember. So I use Google to find them. But you know, you bookmark. Basically, if you find a useful resource, just bookmark it. Put it under like random UNIX stuff that's in my web browser, and then when you need it, you'll find it. Or just use Google and don't bookmark anything and just use Google. Truly arcane specific things that have come in handy many times. I put in like an Evernote document, and I have like my Evernote document of useful stuff that I never remember and can never find on the internet using Google. And so you may develop your own. Okay. You know what? I think I'll just do this. I'll do this, and then we can revisit it after a coffee break. So you can move around to different directories or folders at the command line. And why would you want to do this? Why would you not want to just like click on things and find things that way? And there's a couple answers. So one of them is that if you're on a remote computer, you can't just click on things. The other is that if you're working with bioinformatics programs, you'll often be in a situation where you have a bunch of files in a directory, like all your FASTQ files. And you want to do something to all the FASTQ files, and then you want to have output from each of the FASTQ files. So a common example would be trimming. I want to take all my FASTQ files, I want to run fastqc on them to get the output, and then I want to run a trimming program, and I want to run fastqc again. What this means is that for each one of your sequence files, you're going to have the original file, you're going to have the fastqc output, which is, let's just say 2 files. You're going to have the trimmed file, and you're going to have the fastqc output on the trimmed file, which is going to be like 7 files altogether. And they're all going to be in a directory. If you have like a 20 run experiment, an RNA-seq experiment, you're going to have 20 files. If you just pair it in, you're going to have 40 files to start with. You're going to end up with 280 files in that directory. Each file is going to produce 7. It's kind of insane. One of the ways we manage this, and more likely than not, experience shows you're going to delete one of your original data files when you're trying to delete something else. So one of the ways we deal with this is we have a directory that contains our data, and we have another directory that contains our output, our analysis, our fastqc or our trimming or our massage files. And the data files are read-only. You make sure that like it's super hard to delete them. And then you have another directory that contains the analysis results, and that's, if you delete it, well, maybe you lose a day of runtime work, but
because you've written down all the instructions you've used, it's going to take you like, right? Because everybody does that, right? Again, everybody writes down exactly what they do when they do data analysis. Perfect. When you delete stuff, you're only going to be deleting things that can be regenerated from your raw data. There's nothing. I mean, presumably you have another hard drive with all your data on it somewhere else, but that could be enough. So in practice, what this means is you have at least 2 directories that you're working in. You have your raw data directory plus your analysis output. And so you have already 2 directories. And in fact, those of us that are too clever for our own good often have like 6 directories.